to solve by graphing. So algebraically, we would distribute this out, x minus 3 times x minus 3, move all terms to one side and solve by factoring. But in this case, we're going to find our answers in the graph. How we tackle that is we see this as two different equations. Y equals negative x plus 9, the term on the left side, and then y equals x minus 3 squared plus 4. There is some memorization that you have to have down for these. For example, when you don't see any exponents or any parentheses, nothing else other than variables and numbers, that is a linear function. So you know your line is going to be a straight line. And that's when we're going to be referring to the y equals mx plus b. So we're starting at a y-intercept of 9, and then the slope is negative 1 over 1, so that means we're going down 1, right 1, down 1, right 1. I'm going to try and be a little bit neat as I pass my points through, because you do want to find the points of intersection. And then same idea with the vertex form for quadratic. So if ever you see an exponent of 2, you know it has to look like a u, and that your vertex is going to be at the h and k. So this is the y equals a times x minus h squared plus k. Your a value in all of these problems throughout this course is going to be 1 all the time. So you don't have to worry about finding it when there's other terms. So I see in this case we've got a vertex at 3, 4. And when I plot that, I can use this new rule that we've discovered, where if you go up 1, right 1, you can go up 3, right 1, and then up 5, right 1. So it goes all the odd values for each slope when you pass between each of the new points. So 1, 3, 5, 7, 9, just like that. So if I go up 1, right 1, it lands me at that point. Up 3, right 1, lands me at that point. I could try going 5, but there's not enough space. So up 1, left 1, up 3, left 1, and then up 5 takes off the page. So it looks like I've got 2 points of intersection, but my equation only has x's. So we're just solving for the x value at those 2 points. So that would be at positive 1 and at positive 4. So x equals 1 or x equals 4. With the radical functions, the square root symbol kind of follows the same path of what your graph is going to look like, because it kind of looks like that. It starts at a point and keeps on going to the right. And the way that we can graph that is the same idea with the vertex form. So it's the square root of x minus h plus k. I don't see any number on the outside, so I can think of that as adding a 0. So it'll be negative 2, positive 0 for my vertex, which is on the x-axis right there. For the radicals, it's starting at your h and k, and then you're growing it to the right. So it goes up 1, right 1, so still with the 1, but then up 1, right 3, and up 1, right 5, and then 7 and 9. So it's the opposite of how we would do the quadratic function. So up 1, right 1, up 1, right 3, up 1, right 5, gets a graph that looks like this. For the absolute value, we're going to start with our vertex again, x minus h on the inside plus k on the outside. So it looks like my vertex is going to be at 2, negative 2. And when we graph this one, it's just using your a value, which in this case is a 1, to go up 1, right 1, up 1, right 1, up 1, right 1 all the way. And then you can repeat that pattern going in the other direction. That lost its pathway there. There we go. So up 1, left 1, up 1, left 1, up 1, left 1. So the absolute value function looks like a V. You can see that because absolute value with the V. So this is going to be 2 points of intersection. One is at negative 1, so x is negative 1, and then x is positive 7. So I'll put up a key to this so you can look at this later to see how you're doing with the other problems, but that's how we solve by graphing.